Alright, so this marks the start of the second section of our 7 and 8 here, practicing different math problems for the ACT. And this first question is a pretty straightforward one in terms of it's just asking you to solve for x. So on this one, for example, you would add 16 to both sides, you'd get 3x equals 21, and you solve that, divide both sides by 3, you get x equals 7. Now the only danger with this first problem here is that when you get your x, kids will be tempted to, oh look, it's 7 right there, and they'd be done. They ask for the value of 5x though. So the only thing is once you get your x right here, you have to plug it back into the equation. 5 times 7 is 35, making C the correct answer for the first problem. On my second question over here, I have an absolute value, and on the inside I have that -2 minus 7. Well, -2 minus 7 is a -9. You do what's on the inside of the absolute value first. You cannot distribute into an absolute value. If I do the math on the inside, I still have that -8 on the outside, and I have a -9 on the inside here. Absolute values take whatever was inside of them, and it makes it positive. So this is going to give me a positive 9. So then I end up doing -8 times a positive 9. The number on the outside gets multiplied against the inside here, and I end up with a -72 for my answer on that one. So that makes choice C as well. If we're talking like you're just randomly guessing right now, this is how you actually do the problem. If you had to randomly guess on this one, just as a side comment here, notice that -72 and 72 are both choices. So if you're just guessing randomly anyway, if I see that problem, I'm probably going to think to myself, I have to just pick a random letter anyway. I might as well pick one of those, because it's interesting that they chose the same number, but opposites, one positive, one negative. So moving on to number 3 here, I'm looking at this question, and my goal on this one is to try to take that equation, and I am going to get x in terms of p and q. In other words, I'm going to isolate x, or get x all by itself. So I'm going to write down my equation again a little bit bigger. I got to get x by itself in this equation. The first thing I'm going to do is get rid of this divided by p, which I'll do by multiplying by p on both sides. These are going to cancel out. I just get 3x equals q times p. So I'm almost done. To get x by itself though, I just have to divide by 3. So my answer ends up being x equals q times p over 3, which is the exact same thing as p times q over 3, which is choice H on that one. Alright, my fourth problem here is talking about a bunch of numbers, and it's giving me some inequalities comparing those two numbers. What I would do here is kind of make a number line, and take each piece of info as it comes at me. This first part says that V is less than W. So in other words, V on my number line has to be smaller than W. So maybe I'll put my V right here, and my W is going to be further along there, because W is going to be bigger than V. Next up, they say y is greater than x. And I'm actually gonna ignore this one for now, because x and y, I don't know if those go over here maybe, or over here. I'll come back to that one. So I'll circle that to let myself know. This one I took care of. I need to deal with this still. This one actually has a v in it, so I can kind of address it with respect to the letters I have already. Y has to be less than v. That's what this tells me. So I'm gonna put my y to the left of v. So I dealt with this piece here, and this next one says that z is bigger than w. So z has to be bigger than w. It's going to be somewhere over here. And the last piece of info I need is this one over here that y is greater than x. So y has to be bigger than x. X would go somewhere in this area. They ask for which one of the numbers is the smallest, and once you have them all arranged like this, it's clear that the answer is x, which is choice C. Moving right along to number 5 here, we're talking about triangles that are similar. So you'll have to think back to geometry for this. And they talk in this problem about a ratio. There are lots of different ways to do ratio. I'm going to go ahead and draw 2 triangles though that are similar to each other. They don't have to be right triangles, but it's good to have some sort of a picture here. They say that the sides of these triangles are in the ratio of 3 to 4. In geometry, you probably did something where you set up 2 fractions and you cross-multiplied and all that. I prefer to think about ratios with variables in them. If they say that the ratio between the 2 triangles is 3 to 4, that means I'm going to call my sides 3x and 4x. If they said it would have been 7 to 8, 7x, 8x. It's just whatever they give you a ratio, you just put a variable on the two pieces. So the matching sides, the corresponding sides, I have a 3 to 4 ratio, so 3x and 4x. It's going to be the same sort of deal. I can't use x again, because that would mean that they're the same size. But like this could be 3y and 4y. This could be 3z and 4z. Those pieces, actually, the y's and z's aren't actually necessary to solve this problem, but that's what you could do with this picture. So they say that one of the larger sides in the triangle is 12 feet long. I'm going to just go with x. So I'm going to pretty much ignore the y's and z's here. I won't need them. I know that this side right here is 12, so I'm going to solve that for x. You end up getting x equals 3. Well, once you know what x is, you can just plug it in, because they want to know this corresponding side in the smaller triangle. Just plug it in right there. 3 times 3 is 9. That's how long this side is being, which is choice H. So number 6 here is a question that actually is a systems of equations question. So if you remember that from your Algebra 1 and or Algebra 2 days, a system basically is two equations, both with two variables or more in them. And we can solve those. So I'm not going to explain how to actually do a system on this one. I'm just going to kind of show the example. If you don't know how to do systems, I'm going to show you a quick second way you can also do this problem. But for those of you that remember systems, the two things we don't know are the cheap stamps and the expensive stamps. So x is going to be my cheap stamps, and y will be the expensive stamps. We have two things we don't know. We need two equations. The first thing they tell us is that we have 65 stamps altogether. X is how many cheap stamps, y is how many expensive stamps. So I know that x plus y is going to equal 65 in this problem. Secondly, I'm told that the stamps cost 20 cents or 45 cents, and altogether they were $25. So that means that 0.20x plus 0.45y equals 25. The cheap stamps plus the expensive stamps equals $25 altogether. Now this is just a problem that we're going to solve. It's a systems problem. I showed you guys if you had me for Algebra 2, you would know already how to do this in the calculator. That's an option you have. If not, you can always just use elimination. So I'm going to multiply both sides by negative 0.20, and I'll rewrite my equation down below. Negative 0.20x minus 0.20y equals, I think that's going to be negative 13. I'll double check that though. Yeah, that's going to be negative 13. So now we're just going to add going straight down using elimination. This doesn't matter anymore. These x's cancel. I get 0.25y equals 12. I'm going to divide both sides by 0.25, and I'm pretty sure that's going to equal 48 when you do that. 12 divided by 0.25, yeah, that's right. So, sorry, I went off the screen a little bit here. You get y equals 48. In the problem, they asked for how many expensive stamps. That's exactly the answer right there. It's 48 expensive stamps, which is choice G. Let's say you forgot that, like, all this right here is confusing and you don't know how to do systems. Another smart option is just kind of guess and check with your answers. They give you answers here, plug them in and see what happens. So if they bought 17 of the expensive stamps, we're going to take a choice right here. I'll show you how you would do that. If you had 17 expensive stamps, that means that you would have 65 stamps altogether. 65 minus 17 is going to be a 48. So you would have 48 cheap stamps. And then what you would do is actually figure out how much that would cost. If you do 0.20 times 48 plus 0.45 times 17, that's going to be 17.25, for example. So that's no good, because that's not enough money. And you basically just guess and check. If we have 48 of the cheap ones, then you do 65 minus 48, we're going to have 17 of the expensive ones, and you figure out the price, and that one will end up working. Choices, well, choice K especially, doesn't make any sense in this problem, because we have 65 stamps, you can't have 125 expensive ones. So this takes us on to our last problem for the video, which is the most challenging one, because it involves composition of functions, which is a Algebra 2 topic. So if you haven't been through all of Algebra 2 yet, this is probably not the sort of question you're going to spend a lot of time on when you're taking the actual ACT. But if you'll recall, f of g of x means you take g of x, that function right here, and you're going to throw it in for x in the other function. So the thing on the inside gets tossed into f. So f was x cubed, but, sorry, f of x is x cubed, but we want f of g of x. So really this is f of x over 2 minus k. That's what g of x is. So I'm going to toss this whole thing in for the x in f of x. So I end up with x over 2 minus k cubed. Instead of x cubed, I take thing I'm plugging in cubed. So they tell us a point on this one. They say that if you plug in a negative 2 for x, you should get out, this is my, basically you can think of it like the y right here, I will get out an 8. So I know that if I plug in a negative 2 for x on the inside of these parentheses here, I should get out 8. So it's really just a matter of kind of playing around with this and figuring out what number k has to actually equal. Negative 2 over 2 is negative 1. So I get 8 equals negative 1 minus k cubed. So there's a couple ways you can handle this right here. Yeah, again, if you've taken algebra 2, you can do like the 1/3 power on both sides, or the cube root of both sides, or you can just think about it. What number cubed equals 8? Well, 2 cubed equals 8. That means the inside right here has to equal 2. So you just have negative 1 minus k equals 2, and it's just a matter of solving this problem right here. You add 1, negative k equals 3, so that means you get k equals negative 3, which is choice H. It looks like almost every problem on this worksheet was either C or H, with the exception of number 6. Totally accidental, but that's part 2.